Welcome to Würth Knowing. Today, we're going to talk about structural bolt testing. And wouldn't you know it, I have our resident expert, Chris Treble here. Chris, welcome to Würth Knowing.
Happy to be here.
So I actually, for once, want to show off my knowledge a little bit about testing because I have worked in the fastener industry for ages. I know that depending on which type of fastener you have, you perform different tests. The one that I'm familiar with, or the tests that I've heard about all the time, are mechanical and chemical. Is that all we have for structural fasteners? I know 100%?
No, but that's a really good start. You're right. So in structural bolting, it really kind of breaks down to three groups. There's the mechanical and chemical testing, there's what's known as rotational capacity testing, and then pre-installation verification testing. Each of those along the chain are all kind of done by separate groups, and so that's really kind of what we want to dive in today with. The mechanical and chemical testing with structural fasteners.
Because I do have a question. People always say these two words together. Can we break it down and start maybe with mechanical testing first? Because otherwise I feel like people feel like it's one test.
Definitely, no. So mechanical testing, ultimately what we're referencing to is the physical shape of the part, the thread fit, the head height, and then also the physical properties. Once you have a finished part, when you do the testing, be it for tensile testing or Charpy impact or any of those kind of tests that go along with the physical properties of the part when it's finished, from how it's made to what it looks like when it's ultimately finished, they're gonna make sure that all of those pieces fall within the specification.
This is not an easy video to film for me. Chris, I'm sorry, I don't know anything about testing. Now, I didn't mean to brush over chemical. So chemical, from my knowledge, is like you're trying, for example, to look at the carbon content of something. What else would be chemical, or how would you describe chemical testing?
Exactly. So chemistry, sometimes you'll hear burning off, and it's essentially they're going to get the chemical components of the steel to make sure that those are also within the specification. Each of these product specifications are going to lay out what the expectations for minimum carbon content, nickel, molybdenum, whatever the other chemistry that needs to be in that part to make sure that it's within the specification.
And usually that step is done by the manufacturer, right?
It is, because the manufacturer is going to ultimately be the one that's putting their name on the part. They're going to do all this testing, and then they're going to certify that this part, by the time it gets to you being distributor, you being end user, whoever, that it is within the specification because they're ultimately responsible for that. I did it again, like I just stopped talking and it was like, there's words there. What?
Now, Chris, I am curious though, because you mentioned two other types of tests. One was rotational capacity testing.
Yeah.
Is it kind of like what you expect from the name?
A little bit. So rotational capacity testing is unique to the F3125 fasteners. It's really designed initially when they started putting coatings on them. The coatings would kind of gunk up the threads a little bit and it would affect the performance. So this test was developed to make sure that once you've coated the part, all these components are still going to work together. So really when you do this test, you're looking for a lubricity, that there's some sort of lubrication been added to one of the components. You're looking for thread fit, and then ultimately that the part's still going to perform how you want. So those are the keys when you're performing these tests.
And my question would be, who performs this test? Because I kind of can think of the manufacturer trying to do it, but there could also be other steps in my thought process.
So it really kind of depends on who's requesting it, but some manufacturers will perform this test depending on how they're packaging their fasteners. More often than not, you're going to see it done by the suppliers. The ultimate goal is going to be who's requesting the test, whether it be an end user or some kind of third-party organization, a government organization, a project owner, something like that. So it can be kind of done up and down the chain, but more often than not, you're going to see it done and performed by a supplier of these parts.
Now, whenever we talk about testing, there's like one big question mark in my head. Does a failed test always mean a bad product?
So in this case, no, as silly as it sounds, because the bolt is made to a standard and the nut is made to a standard. They could both perfectly be within their specification, but not necessarily work together. So it doesn't necessarily mean that any of the parts are bad. It just means that the connection's not going to work as you have it. So ultimately you need to change out your components, retest, and make sure that you find an assembly together that's going to work and perform how you want it to.
So it's kind of like a real life example of phone chargers where everything is a phone charger, but they might not work.
100%. They may not necessarily sync. They could be designed to work together, but not everything's going to work as you want it to interchangeably. So you have to ultimately do this testing to make sure that you know you're getting the performance that you need.
So what you're saying is you can flunk a test while still being a success just if you change your environment.
Definitely.
I don't know if it was too early for you.
No, that was an exceptional segue. Like, I'm pretty sure my face was like, ooh, ooh, he's good. Did you see what he did there?
Now, Chris, I know there's one more test left. Does it connect in any way to this array of things that we have on this table?
It does. I brought a bunch of stuff just to mess up your table. But no. Ultimately, these are the kind of tools that you would see typically in a structural site. The tool that you choose is going to be determined on your installation method, whether it be pneumatic tools or electric tools. It's an electric shear wrench, a torque wrench, the spud wrenches, but ultimately pre-installation verification, what we're testing is our tools and our method. So you're going to start with a bolt tension measuring device. This is a beam mount. This is a bench model. Regardless of what type of bolt tension measuring device you use, all it's really doing is confirming that if I take these tools and this lot that's been exposed, how everything else on the job site has been, if I follow my method, will I get to the appropriate tension? Find out on the ground before you go up in the air.
Now, is it basically, I'm still back thinking about RoCap testing and it being for one specific type. Pre-installation is for all the types, or is there also a limitation to it?
It is. So the RCSC specification, the Research Council on Structural Connections, in Section 7, they spell out the need for pre-installation verification. Depending on your joint type, depending on your material, they're going to tell you exactly when it needs to be done, as well as who needs to be performing this test. So it's performed by the bolting crew on site so that the material, again, we're checking, are the tools working? Is the method working? With the condition of the lots we have. Each lot's gonna get tested to make sure that it performs as we expect it to.
So a lot of testing is done to ensure the safety, the quality, but also the right performance of a structural bolt.
Definitely. The biggest thing we're concerned about is, are they gonna perform as designed?
So we are doing a lot of testing for structural bolts, but that also makes sense to me. I mean, we're trying to ensure the safety, the performance, the quality of these really important products that hold together a lot of critical infrastructure. Am I forgetting anything?
No, you're 100% right. This kind of niche group of parts are so important in our infrastructure with the bridges, the buildings that we live in. They want to make sure that we're covering all the bases from how they're manufactured ultimately to how they're installed, and make sure that we're hitting all the expectations of the performance.
And now I know that after mechanical and chemical testing, there's RoCap testing and pre-installation verification. So easy 3 steps, right?
You got it.
I don't think anyone could have explained this better to us than Chris. Thank you so much for being here, and we're looking forward to seeing you on another episode of Würth Knowing.
I lost it again. Like I just stopped talking. I've got to quit making a face when I go blank, because then you could just be like, yeah, he's done talking.
Just cut to me doing the Jim Halpert.
Because I'm always like, ran out of words to say.